Hello, everybody, and welcome to Hash Rate. My name is Mark Jeffrey. My guest today is Dominic Williams of DFinity. So, hello, Dominic. Welcome to the show. How you doing, man?
Yeah, hi, Mark. Thanks for having me.
So, where are you in the world? I just want to make sure people know that.
Well, right now I'm in Zurich, which is where the DFinity headquarters are based. And it's sort of like, it's actually quite a big building. It's like an 8-story building. And we're in the basement where we've got this little kind of thing set up for podcasts and stuff.
Yeah, I love it. You have a great set, by the way. Most people that come on here just, there's no set, there's nothing. It's you're very buttoned down. I like it. It's very impressive. So well
Thanks.
done. So I want to talk a little bit about what you guys are up to. So I've heard this claim of we do DeFi, we do Bitcoin DeFi like 1,000 times. And this is kind of a holy grail. It's very significant if you can crack this because there's $500 billion in Bitcoin sitting on the sidelines right now that can't get DeFi yields. And I'm one of those people. I got like a big pile of Bitcoin. I've been playing in DeFi ever since it began. I can't really use my native Bitcoin. Now, I could move it in via a bridge, right, into wrap Bitcoin. And a lot of people do that. Like 1% of all Bitcoin is wrap Bitcoin. So it's not like, it's not like there's not a way to do it. But it's sort of squirrely. Bridges have been the source of a lot of hacks, right? So you don't really know if you're going to ever see your Bitcoin again. There hasn't really been a hack of wrap Bitcoin that I'm aware of to date, at least not a significant one. I don't think there's been any. So it's probably pretty safe, but you never know. We could wake up one morning and find out that bridge has been hacked and it's all gone. But every time I investigate somebody with this claim that they're doing DeFi Bitcoin, there's always a wrap token and there's always another chain, right? So I feel like Fred from Scooby-Doo, like unmasking all these things. So I'm very curious when Tom Saras on Twitter was insisting that what you guys were doing was different. I was like, it's probably the same old bullshit.
It is, yeah.
And I went and looked into it, and I found out that the big news is that you have implemented Bitcoin addresses within Internet Computer smart contracts. And this is like native Bitcoin addresses. So you have exposed it to true DeFi. And I was like, wow, this is different. So tell me about this big news and kind of how it works.
So, DFinity, where I work, is a not-for-profit foundation, and we're the main contributor of technology that powers this thing called the Internet Computer, which is you can think of it like a world computer. It's a sort of blockchain that introduces a lot of new technical principles and cryptography that scales. It has a lot of kind of interesting capabilities, like smart contracts can serve web. If people are wondering how on earth something as slow as a blockchain transaction could serve an HTTP request, the answer is that it's pre-finalized. So you pre-finalize a transaction that would serve index.html, and then you can just serve the transaction to somebody who's asking for index.html, and they can verify. So it scales. It's very fast. It can serve web.
So just be clear, when you say can serve web, the smart contract itself is a web server also and is serving to the web directly?
Yes,
is that
exactly, precisely. And what's very cool is that you can do it raw, but the proper way of doing it is to pre-finalize a transaction that serves a web asset or some bit of data, and that transaction is effectively signed using something called chain key cryptography by the blockchain itself, and we'll get to that. It's the same thing that's used for Bitcoin. And the browser, typically will have a service worker installed that transparently verifies that chain key signature to make sure that the web asset was actually served by a transaction. So that's very novel, and it means that you can create end-to-end decentralization. And our vision is something called blockchain singularity, where we enable everything to run 100% off blockchain. And part of that is achieved through the Internet Computer blockchain and its unique capabilities. And part of it's achieved through, we plan to achieve through multi-chain, and we'll get to that. The Internet Computer is designed in a very different way. So it runs on something called proof of useful work. It doesn't run in the cloud. It runs on a sovereign network of these things called node machines, which are specialized but publicly standardized hardware. It's not proof of stake, albeit it's controlled by a governance system where people stake governance tokens. And among the unique features, for example, smart contracts pay for their own computation using a system called reverse gas. So they're a bit like Tesla cars. You charge a Tesla car up with electricity, and it drives around and burns through the electricity, and it needs refilling with more electricity, or it stops working. That's the model for smart contracts on the internet computer. And you combine that with web serving, just absolutely insane levels of efficiency and other things, and now you can actually build services end to end on the internet computer. So with respect.
Let me stop you for a second, because I want to make sure. I want to so there's a lot to unpack there. So I want to try to make it as simple as I can. And I did do my homework a little bit before we got on the phone here, and I think I understand a lot of this, but I want to kind of repeat it back to you, and you tell me whether I've got it right or not. So internet computer is actually a materially different blockchain from a lot of the EVM things. There is somehow more on the computational aspect of what it does, and in some ways, and so you, instead of smart contracts, you have things called canisters, and they have some different enhanced characteristics from what people like me, who are EVM heathens, are used to, right? So, and you're sort of, I think you guys are shooting for sort of a third generation blockchain, if you consider the EVM chains to be sort of second generation. And I just want to go back to what I think is the headline here, which is you can now use Bitcoin addresses inside these canisters, slash smart contracts, and the magic, the way you're doing it, is the validators that you just discussed, which are not proof of stake validators. They are approved by a DAO, by a council, so that's how people are admitted. These validators, in aggregate, hold sharded keys. I don't know if sharded is the right word, but broken up keys for all of the Bitcoin addresses that all canister smart contracts on internet computer use. And that is basically the security model. And anytime a smart contract wants to execute any sort of Bitcoin transaction, a majority of the validators have to agree that is a valid transaction and supply their key shards in order to enable that transaction. That's awesome. Did I get that right?
Kind of. It's a fairly good description. So, I mean, and you mentioned the word canister, and for your listeners, I mean, the internet computer is a ground-up rethink of blockchain, and it's not necessarily designed to replace other blockchains. I mean, Bitcoin's merits, one of Bitcoin's key merits is its simplicity, right? It's kind of digital gold. But it was designed to enable this idea of blockchain singularity, where everything in the end is built on blockchain without cloud. The internet computer could run a social network, for example, but when that social network was built, it would have, it would work in a very different way. It would be end-to-end decentralized on the internet computer, and it would be controlled by a DAO, not in the way that you see DAOs control things today, but using a special kind of DAO called a service nervous system that is capable of fully controlling the service, updating all its software, configuring it, and so on and so forth. So it's the complete removal of centralized tech from the stack, and and enabling the reimagination of everything from mass market internet services through to enterprise systems. That's what we were driving towards. And back in the day, in 2015, the project really was meant to be Ethereum 2.0. That's what the research was originally directed at, but it just became apparent that this thing would have to be a different project, because everything would have to be rethought, everything would have to be re-engineered, and it would take years and years to produce. And then here we are today, and then the reason canisters, smart contracts are called canisters or canister smart contracts, is they work in a different way to traditional smart contracts. They're asynchronous, so they can run in parallel. That's one which is essential to allow a blockchain to scale out, and it's able to have calls between these different smart contracts run asynchronously, but still deterministically. So, which is one of the things that you need if you're going to.
That's interesting. So this idea, I want to go back to this idea that you want people to be. There is no Amazon cloud. So basically, internet computer becomes the new cloud that everyone is building on top of, but it's blockchain. Its atoms, its molecules are blockchain. so it functions differently. And this is why Canisters can serve web pages, because it needs to act in a cloud-like manner as well as a blockchain-like manner, and you're fusing the two of those, lacing them tightly together.
Yeah, I mean, look, it's completely. You couldn't take a cloud app and put it on the internet computer. You can't like run, it's still a pure smart contract environment. And the reason they're called canisters is that one, they are synchronous, and two, each smart contract consists of a bundle of WebAssembly bytecode rather than EVM. WebAssembly is the new virtual machine of the web. Actually, one of the co-designers of WebAssembly worked at DFinity, and it's a bundle of this WebAssembly bytecode which you can create using any language pretty much. Popular ones are Rust and Motoko today, but there's all kinds of kits, for TypeScript, Python, that are sort of becoming, more stable and more production ready over time. And persistent memory pages. So it also has a thing called orthogonal persistence, which is one of the ways that we've been able to greatly increase the efficiency of smart contracts, as well as make it much easier to create very sophisticated computational systems of the kind that you need if you want to build something like a social network on the blockchain. So that's why they're called canisters, because they're this bundle of WebAssembly bytecode and persistent memory pages, right? But they're still smart contracts. A smart contract essentially is something that provides a bunch of properties, right? And the properties are it has to be tamper-proof. You don't need a firewall to protect Bitcoin. Bitcoin doesn't have a firewall around it. Doesn't mean you can steal the Bitcoin. Right. You don't have a firewall around Ethereum. Doesn't mean you can just arbitrarily hack an Ethereum smart contract. It has to have some flaw in its design. And similarly, if you build something on the internet computer, you don't need a firewall around it because you're building with smart contracts, and that's pretty revolutionary. That's one of the key defining aspects of a smart contract is tamper-proof. Right, it always executes the code that it contains against the data that it's meant to run against. So, the canister smart contracts do that. They're unstoppable. They can process tokens, for example, and they can also be made autonomous. And when I say made autonomous, by default, when a developer uploads a canister smart contract to the internet computer, they retain a key that allows them to update it. You can update these smart contracts. There's a controller ID, right? Yep. But if you want, you can set that controller ID to null. If you do that smart contract can't be updated by you or anybody else. It's obviously autonomous. It just exists. And, other people could send it gas, which is called cycles on the internet computer, to charge it up, and it'll keep on running forever. So that's an example of autonomy. Another example of autonomy is that you change that controller ID to point at a service nervous system DAO. And thereafter, that DAO has complete control of that smart contract. Now, if you want to build something very complicated, like, I keep mentioning a social network, but anything's possible, a metaverse, games, enterprise system, what you can do is have a kind of hierarchy of smart contracts. So you have like a management contract, right? Mm-hmm. And then all of the other contracts are controlled by that. And then the management contract is controlled by the service nervous system. And actually, this model is just sort of rolled into effect. A few days ago, there's a thing called OpenChat, and it's a very, very sophisticated messaging service that's really social-fi because it blends like social features like messaging with DeFi. Because what's interesting, we'll come back to this and how it relates to Bitcoin, that your chat account is a crypto wallet and you can send crypto with chat messages. And that's possible because it's all built on smart contracts. It's not running on Amazon Web Services. It can't be hacked. The developers can't turn it off. So then it just assigned itself to a service nervous system DAO. And now, going forwards, all updates to OpenChat have to go through the DAO. It's not like the developers have direct access, can update it themselves. And so now it's becoming more like a community-driven thing. The service nervous system is a very sophisticated digital democracy, effectively, that allows it to take over full control of pretty much arbitrarily complex services and systems. So
let me stop because I want to return for a second back to the Bitcoin basically being able to manipulate Bitcoin on a native exchange. I just find that super fascinating. I'm not aware of anyone else who's taken this approach. I think everybody else will once they see what you've done. I think it's extremely clever. But my brain goes to okay. So where is the bridges were the old surface area for attack in the old system. In this system, it appears to me that the validators would be how I would try to get control, how I would try to steal Bitcoin, basically, if I was going to try to do it. And so the validators, you want to try to get control of the validators. However, my understanding is the validators are trustworthy because it's not open, it's not permissionless validation. You have to apply and you have to be accepted by the DAO. And so presumably they vet validators. How are they vetting validators, and how do they know that the validators are good people and not people like me trying to steal Bitcoin?
Well, that's a good question, and it gets into some other dimensions. I first of all just want to talk about proof of stake validation, how it works today. When you dig into it, you'll find that all the validators, in large part, are running on the cloud, and that the validators are anonymous. So a lot of blockchains will say, well, we've got like this many thousand validators, we're really decentralized. It's not really true, because all the validators, first of all, are running on the cloud, and those cloud, a handful of cloud services would be able to take complete control of those blockchains or switch them off. We saw recently with Solana, Hetzner decided they didn't want Solana validators running anymore, and they literally just switched off 40% of the network just by running a script, and it happened in the blink of an eye. Now, that's actually, it sounds pretty bad, and there are many interesting technical dimensions to that happening, because actually Solana should have stopped. It didn't, because they knocked out 40%, and that relates to the mathematics of distributed computing, but it kept going. It would be, but what was far more worrying is that someone would get control of one of these cloud infrastructures, someone nefarious inside these cloud operators, and would actually manipulate them and corrupt them in some way, and mess around with DeFi or whatever they were going to do. So that's the first problem. They're not really decentralized, because a handful of cloud operators can turn them off or potentially corrupt them and use their control that they've given themselves to steal things, including wrap Bitcoin, obviously.
Sure. Completely agree.
The other piece is that we don't know who's running these validators, and I can tell you from personal knowledge that oftentimes you'll get whales that are running thousands and thousands of these validators themselves. Oftentimes these new proof of stake projects, aren't credited by, not-for-profit foundations, they're credited by for-profit companies, like whether it's Avalabs, Solana Labs, IOHK, Nearing, which is now renamed to something. And, they're really for-profit ventures backed primarily by, these companies. And that's where all the VCs invest, the tokens are held, and the value's created. And sometimes they create foundations for their window dressing. Those organizations themselves often are running a lot of the validators, so they can essentially, as marketing, to say, look how decentralized it is.
Right.
But it's decentralization theater, and the reason why, it is a decentralization theater. There's no way of describing it, and it's difficult because because everyone in crypto is like, they read about these things. The crypto press is kind of corrupted, and so they just constantly hearing about how these blockchains got these validators and so on and so forth, and people naturally just interpret it. It's like TVL, right? Like, now it's come out like TVL on Solana was completely fake, and, we can see exactly how it's created. And this is decentralization theater, and it's a way of selling blockchain tokens. And, recently Avalanche promoted this fact that they've got this deal with Amazon Web Services. Now you can just press a button and instantly create an Avalanche validator, and isn't that decentralized? It's not. It's kind of antithetical, actually. Like blockchain, like if you could talk to the original team that would, credit Bitcoin and try to explain this idea of proof of stake running on the cloud,
they'd hate it.
They'd be horrified. I mean, it's not, obviously, Satoshi was before his time, and I'm sure if he's still around, his ideas would have evolved dramatically. But the basic theory is sound. Like, the security of a blockchain derives, on some of the benefits it provides, derive from getting rid of intermediaries, right?
Yeah.
And so look, if you
So getting back to the validators. Yeah.
So in case, so look, so we use something called deterministic decentralization, and I try to explain why. So if you look at Ethereum today, I believe it's got 500,000 validators. And those 500,000 validators, I believe, again, it's theater, and it's also a way of getting people to lock up their tokens to reduce liquidity on the market and things like that. But they're all replicating the data and computation being performed on Ethereum, supposedly for security, but there's no mathematical basis for this. And if you laid out all those validators, those proof-of-stake validators, and you conceive of them as separate computers, although they're cloud instances, and you lay them out in a line, one every meter, this line is going to extend 500 kilometers. And all these computers in this 500 kilometer long line are basically doing the same stuff for no security benefit at all. And we don't, and yet, despite all of that, they could all be switched off by a cloud operator. So on the internet computer, we believe really the network should run on dedicated hardware. I use a thing called proof of useful work. In order to create a world computer a blockchain that can have the same efficiency as a cloud, because we want blockchain singularity, we want the whole, everything, pretty much the majority of humanity's services and that we use every day and enterprise systems and so on running on blockchain. You've got to drive efficiency really hard, and you've got to get efficiency from where it is on these proof of stake blockchains, tens of thousands or hundreds of thousands times better, so that it's in the same ballpark as traditional tech, right? And that's what we've done. The way it works is inside the internet computer network, you have these things called subnet blockchains. They're nothing like the subnet stuff you hear about Avalanche, which is standalone blockchains. These are special. These really are subnets, and they're combined using by this thing called chain key crypto into one blockchain. But each additional subnet that you can't see that's inside the network adds additional capacity to the internet computer, and it's created using a thing called deterministic decentralization. And that means that the node providers, the people, the independent parties who are running these node machines around the world, from different data centers and different geographies and different jurisdictions. Whenever a subnet is created, deterministic decentralization selects nodes run by independent node providers from different data centers and different geographies and different jurisdictions, thereby creating a Nakamoto coefficient that's sufficient for the specific
requirements of the subnet, and that's another sort of topic. But so you'll find
sorry, you lost me there. You lost me. I was following up.
So actually Bitcoin is held, or rather the keys and this kind of stuff that you mentioned, occurs on subnets with higher degrees of replication than others, and that relates to the fault tolerance of some of the threshold cryptography schemes that are applied. So that's what I mean when I say the deterministic decentralization system is creating a Nakamoto coefficient that is sufficient for the specific task at hand. Okay. So and obviously we've got a large number of cryptographers here, and this is something that's looked at a lot. Now, there's another aspect to this. Okay, so let's say you've created a subnet which is going to be doing a whole lot of this kind of chain key crypto magic, right? That enables smart contracts to directly hold and send Bitcoin, which is incredible. There's a whole lot of analysis that goes on. There's this thing called the network nervous system DAO that controls the internet computer network. So there's no forking. It's not controlled by DFinity. It's not like a traditional blockchain where there's a sort of cabal of insiders that kind of work with the validator operators and things like that to run upgrades. The internet computer is updated by a thing called the network nervous system, which is a kind of super advanced DAO. It's worked very well. It's updated the blockchain hundreds of times, and it's, what is it going to be? How long? 20 months, something like that? More, 21 months of running in production. It's only ever been like 1 second of downtime or something crazy.
So a little bit better than Solana.
And that thing has, that thing is, looking at these node provider profiles and saying, right, we're going to combine nodes from these node providers and these data centers and these geographies and these jurisdictions. And you're doing this for a variety of reasons. You don't want everything in the same geography. I mean, going back to some of the old reasons for the internet or some of the, things that led into it, you want to be able to create something that can withstand a nuclear strike. So if you have, all the nodes, but look, you could get nodes from independent node providers,
put them in different data centers, but all the data centers around Amsterdam. Someone puts a nuclear bomb in Amsterdam, stops working, right? So, you want to have different node providers, different data centers, different geographies, like the data centers should be in different parts of the world. You don't even want them all, though, in the EU, because imagine if the EU suddenly banned blockchain. Well, again, it stopped working, right?
We all agree.
Yeah. So, okay, so you've done that. Then you come down to this question of like crypto economics. And the question is, what stops the node providers colluding, right? And, I can find out who these other node providers are in my subnet and sort of do like some, special deal with them. And I'll come to that because it's actually a very interesting.
First of all, how many node providers do you guys have right now?
It's not, I think it's like 71, but I'm not sure. And they tend to operate quite a large number of nodes from different places. So nodes are like, and there's like 1,200 nodes, and we've got more than enough capacity, but we're trying to push people to expand partly because we're trying to get, we want to encourage people to create nodes outside of the USA. We'd like to see, in the end, we'd like to see less than 25% of the nodes in the US. And that's just,
I can see why.
Yeah, your regulatory environment's unclear and things like that. And we think the internet computer would be better off, balancing better around the world. And there are new node providers coming all the time. It's been made much, much simpler than it used to be. You can build your own node machine to the public spec. You can buy one. There are people that make them. But it's a very different kind of thing to like proof of stake. It's less speculative. The network will give you, the network is actually modulating the number of ICP you receive, so you get relatively constant returns. Currently, I think you get about 2.5x your investment back over 4 years. The node machines actually cost more than they used to because of all the supply chain issues after COVID. So I think they cost about 20 grand now. And people oftentimes, to make it worth it, will run quite a few of these things. But
the node machines have special requirements, so it's very much in one sense. I don't want to dig up the make you go crazy here, but it's sort of like Solana in the sense that the machines they have to be beefy machines. There are special requirements.
Yeah, well,
you can't just run it on your own machine.
They are beefy. I mean, the reason though, what they're trying to do is just run this entire network on. Every machine is running an entire copy of the network.
Yes.
On the internet computer, these machines are running under the control of the overall network, the network nervous system, which runs on its own subnet. But they're really processing only the computation data on the subnet they're assigned to, and then sometimes like backup key material and stuff like that from other subnets. And you can imagine all kinds of like stuff that goes on inside the protocol to make sure like key material is never lost in the case of ECDSA keys, which could be used for Bitcoin. The process now, it was very complicated before. It's very much simplified. So literally, and these nodes run as black boxes, right? So you literally can build a machine, install the software via USB stick. Once you've created a node provider profile, you can then add the key. Like when the machine installs from that USB stick, obviously it gets like a machine key, and then you can add that to your node provider profile. And now immediately, as soon as the network needs more capacity, it can just pull from you, right? Pull your machine in. So it's hugely simplified. And so it's actually the number of node providers is growing. And there's other kinds of subnet as well. So I think there'll be a lot of growth in that area. But we also I think one of the differences of the internet computer and the blockchains is it's trying to be efficient, right? So it doesn't want 500,000 nodes right now because it wouldn't justify the amount of computation that's running on it. Yeah. And it would just be a cost that had to be borne. And that's, the internet computer has slightly different objectives, often to some other kinds of blockchains. So it's really designed to support the side of blockchain singularity and everything on blockchain. And so we're trying to replace traditional IT. Multi-chain allows us to include other blockchains within that world computer vision. But going back to what's going to stop this really interesting question, like what's going to stop so you've got some subnets, right? And some of the subnets.
It's going to stop bad people from doing bad things.
Yeah. So basically, it's using chain key cryptography. Chain key is this. Public key cryptography is where you have a pair of keys, a public key and a private key, right? And let's say you have a public key and I know it. I can encrypt some data to your public key, but only you can decrypt it using your private key. Or you can send me a message that's signed with your private key and I can validate the signature with your public key. What's cool about chain key is that you can take like existing public key formats like ECDSA, which is used on Bitcoin or Schnorr or anything else, and the public key still exists, but the blockchain takes the place of the private key, right? And it's doing that, of course, by applying threshold cryptography. That's actually the easy part, though. The really difficult part is how do you get the key material onto all the nodes in the subnet in the first place in a decentralized way? How do you update it?
Just be clear. Sorry, I want to make sure everybody's following this. So you're chopping up. The private key is on the blockchain. So the private key is chopped.
Well, it never exists. Strictly speaking, it never exists. So basically, there's a thing called a distributed key generation protocol, right? Okay. Which enables a group of nodes in a distributed computing setting to run this crazy protocol, and then all have these little bits of random data that kind of enable them. They're called key shares, right? And
so not shards,
if some proportion of them create a signature share, right, on a message, that signature share can be combined to create a signature. So
and that is the private key. So the private key has to be assembled like a Voltron.
Well, the private, kind of like the private key never exists because otherwise someone could steal it, right? What's happening?
When you say it never exists, it does exist, but it's never assembled completely together.
Yeah, no one has the whole thing. Yeah, so no one has the whole thing. You have, It's not even, so there's like, gosh, I haven't messed around with this for ages, but there is something called, key sharing, which is a little bit different to threshold cryptography, right? Because key sharing is like, you can take like, RSA key or something like that, and you can like split it up and people can have different bits, and then they can sort of like, everyone has to sign and then you combine it. Like, right? With threshold cryptography, what's nice about it is that only a proportion of the nodes have to sign. And that's very important because, in any distributed computing setting, especially a decentralized computing setting, at any one time, some of these nodes could be offline, or they could be Byzantine, which means that, they're controlled by the bad guy who wants to do bad things, try and steal get people to sign the wrong thing, or steal the key, or just disrupt the network or whatever. So, you have this subnet, and they run this thing called a distributed key generation protocol. And we have something very special called a non-interactive distributed key generation protocol. It's the first one in the world, which is very important in the blockchain setting. And that's really where a lot of the complexity lies. So they're able to run this protocol. And as a result of running this protocol, they now all have these key shares. And they're not, strictly speaking, they're not just a chunk of the private key. There's something else. But what they enable, it's a little bit similar. It's very similar. It's very similar, but just subtly wrong. And then basically that enables the nodes to create a signature share on messages, such as a transaction, right? And then they broadcast that as a blockchain, right? So they broadcast it all to the other nodes. And then once a node has collected enough signature shares, it can create a signature on that transaction. And then, of course, it can rebroadcast that, so everyone has that.
So just to restate, because I think I understand it now, I just want to restate it in simple speak. So it's not a private key chopped up into lots of little bits. It's sort of like that, but it's more like there have to be a threshold, majority or something like that, number of validators who supply their pieces or their key shares. It's not really a shard, it's shares. So they have to check in and say, we agree that here's our piece of the private key. It's not really a private key, but sort of a private key. And that will enable the smart contract.
Well, you never share the private. You never share the key share. You just share the signed thing. So, say for example, you want a Bitcoin transaction signed.
You just sign it. Okay, got it.
Yeah. So what happens is all the nodes independently use this little bit of material they have to create what's known as a signature share. A signature share that on its own isn't a valid signature, and they create a signature share on the transaction, but once the network's collected enough signature shares, they can be combined into a real signature, right? A real signature. Like a Bitcoin transaction, for example, you can actually run on the Bitcoin network. That's how it works. It's a kind of, the whole internet computer actually runs on this technology called chain key. And what we did was we adapted it for ECDSA, which is no mean feat because threshold ECDSA traditionally is extremely unperformant, and we had to do a lot of stuff to make it work within this network setting. So it would be computationally.
But let me ask this, because at some point, right? At some point, the canister with the Bitcoin address has to actually have the private key, the Bitcoin private key, fully assembled in order to execute the Bitcoin transaction.
No, that's the magic. So remember, a canister is just a smart contract, right? So what it does, it has APIs that it calls into. So you can say, so if we actually got specific Bitcoin APIs, and the reason is, as you know, there's like UTXOs and things like that, which can complicate it, and we wanted to make it easier to use for smart contract developers. So, a smart contract can say, give me a Bitcoin address, right? And what happens when you do that is the network is actually constantly running this non-interactive distributed key generation thing, a protocol. And the reason is, even forgetting the new stuff that it has to create, it's also doing it to reshare existing keys. So actually this data is never static. Actually a key share, right, is only valid for a short period of time. And then it's kind of like the material's recreated, and it's done to defeat something called an adaptive adversary. So there's never any really static, even if you were able to incrementally get onto these different node machines, and there's other protections as well, which I won't get into right now. But even if you were able to do that and steal these key shares, like let's say you were some sort of Spectre and you were able to get into all these different data centers and get into the locked racks, and one by one you're accumulating and you think, well, I've only got to get another.
It keeps
30,
changing it.
Yeah, I've only got to get another
like
30.
Two-factor ID.
Yeah, exactly. I've only got to get
always cycling. Yeah,
I've only got to get another 30 of these key shares, and then I'm going to be able to sign the Bitcoin transaction and steal the Bitcoin. Doesn't work actually, because I forget on which interval, but it's very, very regularly. These key shares have been completely remade by a thing called key resharing, which is another thing. So you really have to get a snapshot of the network all at once. It's not sufficient just to steal these key shares one by one. Anyway, so that protocol, the non-interactive DKG and key resharing, all this kind of stuff's constantly running as it happens. And it's creating like new keys for these smart contracts, and it's doing it as well. It's doing key derivation and things like that for efficiency purposes. But you as a smart contract end up with a new Bitcoin address. Okay, so now somebody sends Bitcoin to your smart contract. There it is. It's in your address on the Bitcoin blockchain, or at least what is an address? It's just a
right.
hashed public key, right? But you control, that public key belongs to your smart contract. Your smart contract doesn't have any key material. What happens is, let's say that you now want to send some of that Bitcoin. Okay, so call another API which is going to create the Bitcoin transaction for you, and you want to sign it, right? But actually, it's all taken care of because internet computer nodes talk to Bitcoin nodes, so they'll even send the transaction for you, right? And that's going to happen for other blockchains, but it only works for Bitcoin at the moment. What happens then is, don't forget, smart contracts are replicated computation. So all the nodes in the subnet blockchain that host that smart contract are doing exactly the same thing, and they want to get this transaction signed, so they do, this threshold signing, and it requires some proportion of the subnet nodes, doesn't matter which, to create signature shares on the transaction, and then this is blockchain's a broadcast network, so they all receive the signature shares, and they've all got a signed transaction, and then whichever nodes have been assigned by the random beacon to talk to Bitcoin nodes, then forward it to the Bitcoin network. So the nice thing there is that, you're dealing, there isn't any intermediary in Satoshi, right? The whole point of blockchain is to remove intermediaries, and it's part of the core theory. And, we don't want the cloud being an intermediary. We don't want bridges being an intermediary. We don't, there shouldn't be an intermediary. We should be using cryptography. Obviously it's quite a lot of work to get all this stuff going, but the nice thing now...
This is complex, so thank you.
It is complex, yeah. If you want to see
bearing with me in my questions, because I'm trying.
Yeah, no, it's fine. Honestly, look, for your listeners, just like, I'm chief scientist, and I'm responsible for a lot of the kind of like vision and so on, but behind the internet computer, and but none of this stuff would have been possible with just me. Like, I've got a CTO called Jan Kameny. She's a very famous cryptographer, and he built an incredible team of cryptographers. some of the individual cryptography as well involved in this scheme is incredibly complex, the actual science behind it. So if anyone's interested in seeing some real kind of crazy, genuine moon math, go and look at the non-interactive DKG and key resharing paper on the internetcomputer.org website. It's mind-blowing. And I don't even profess to understand it myself. And the reality is, we've had a lot of, very senior cryptographers looking at this and going through the math proofs and everything else, obviously. We've done this very responsibly, but it's far more complicated than just like a signature scheme, and that's why it took a long time. But this, I think the industry should expect this. Like, we're going to see different flavors of blockchain, and where people want to really push the boundary, and in our case, trying to realize this world computer vision, which for us is blockchain singularity, everything on blockchain, which will provide huge advantages to humanity. If you want to go that far and you want like a blockchain that runs with, tens of thousands or hundreds of thousands of times more efficiency than a simple proof of stake blockchain and so on, you really have to like push the envelope at every single area. Like, you have to change the architecture, you have to have different kinds of smart contracts that run in parallel. You have to have a different virtual machine that's more efficient. You have to, have new kinds of cryptography that, enable that architecture. And inevitably, you're not just able to take stuff off the shelf. You're going to need a team of cryptographers who's just going to sit there working on this, often for a very long time. And then even when you've worked out how to do it, you've actually got to have cryptographers that can code it and audit it and proof check it and everything else to get it into production, right? And so there's going to be there's going to be different kinds and different flavors of blockchain. And the internet computer's purpose, of course, is also to connect these different blockchains in pursuit of this world computer vision. So it's not like, the internet computers, we often call it the world computer. It was designed to be the world computer, but our commitment to multi-chain reflects the fact that actually world computer is really should be blockchain more generally as well, right? And so I think the Bitcoin thing is like going back to the Bitcoin thing's cool because it's going back to the start. And what really got me into blockchain in the first place.
Yeah, it's super cool. And we're coming up at the sort of 45-minute mark here, so I want to start wrapping things up a little bit. Before we go, though, this is available right now on Internet Computer. You guys have released this. Is that correct?
Yes. So the bit that we've been talking about is there now. Anyone can use it. However, that involves working with raw Bitcoin. Right, and as we know, they work at different speeds. So your smart contract on the internet computer has very fast finality in 1 or 2 seconds, but
Bitcoin does not. Yeah,
Bitcoin doesn't. Yeah. So what we did is we wrote this thing called chain key Bitcoin, which is essentially just a smart contract which will be black holed. You can, or updated by the network nervous system DAO. You can check your Bitcoin in and get chain key Bitcoin out. And now you can send and receive Bitcoin, with 1 or 2 seconds finality. It's a bit like a layer 2. Obviously very inexpensively. I think the transaction cost is thousandths of a cent, right? So that's really cool. And then, it's not a bridge. It's like a digital twin because it's a trustless smart contract, right? So it's like you really got a digital twin of the Bitcoin. That you can send and receive very inexpensively and very quickly. And then when you want it back into Bitcoin, you just sort of dissolve the twin, and now you've got the Bitcoin again. Now that we hit a problem, so the technology, all the difficult bits done. The problem was we realized that there's some Bitcoin, because of the UTXO model, Bitcoin can get tainted, right? Like say, for example, it's been on Silk Road or something like that, and North Korea, all that stuff, yeah. So the danger is that someone puts that into chain key, right?
Yeah.
And then somebody else dissolves their chain key Bitcoin,
Could be a
and
nice
then they get this tainted Bitcoin, and they go, I'm going to go and sell that on the exchange. And the exchange is like, no, you can't bring this to the exchange because it's tainted. So this, I think, reflects kind of the real world challenges that people face today. And look, it's just the way it is. So what we're in talks with a number of chain analysis providers. That can analyze the Bitcoin coming in. Now, the thing is, though, it's a decentralized system. It's not DFinity. It's a protocol. We believe in protocols, not systems that are run by companies or even foundations. So the idea is that these providers will interact with the smart contracts themselves to validate Bitcoin that people want to deposit. But of course they want payment for doing this, right? So the proposals are that the DAO will actually pay these services. Yeah. Right. So rather than, and so that's in the works at the moment, and it's going very well, but it's kind of frustrating because we it's like, I'm losing track of time now, but I think 2 weeks ago, 3 weeks ago, we had it done.
Don't happen as fast as you want. I know.
Nothing is always something, right?
Breaks your heart.
Always, yes.
I get it.
I
get it.
Always something.
I feel your pain. I've been there many times.
So what's happened is, that's going, it's frustrating. Everyone was so excited. You have Chainky Bitcoin. Everyone could you could send individual Satoshis, or not quite that much, but like that finely grained. But you could really, it's so inexpensive, so quick. It's like a real game changer. Everyone's super excited. All of a sudden, it's like, has anyone thought about the fact like someone could put tainted?
I wouldn't try that actually either. So.
Yeah. So now. So anyway, but the one thing that has happened, I think, we through the DAO authorized ourselves. We put a Bitcoin in, so some Bitcoins in. I can't remember how much we put in. And then we created these Chainky Bitcoins, and then gave them to various projects to distribute to people to have. So they've got Chainky Bitcoin to play around with. But of course, there's not enough.
Yeah, you're saying chain key Bitcoins, not janky Bitcoins. Just
no, janky. Yeah, Chainky.
It's
CKBTC. It's just like less. Yeah.
They're janky.
Exactly.
Why are
it's
they
like,
janky?
It's like light. If you put it into janky, yeah. And I don't know. And in some ways, it's not fair to call it a layer 2 because you're now subject to the security of 2 different blockchains, right? Whereas Lightning, actually, in principle at least, there's all these kind of weird things with deposits and that person's not done the right thing, so I'm going to make the claim. But in principle, forgetting all that stuff, you're only subject to the security of the.
Yes, and I believe you. I totally buy.
But now it's 2, right? So there is a lot of Chainky Bitcoin. Like if you want to, if you're doing Chainky Bitcoin, and if you're using Internet Computer Smart Contracts, you are obviously subject to the security of 2 different blockchains now. But that's fundamentally different to a bridge or something like that.
It is fundamentally different, which is why I've been trying to get this interview going for a while now. Yeah, because I was impressed when I heard the approach. So what are people?
Just one thing, like this open chat thing. Everyone should look at it because it's like the first true open internet service running 100% on the blockchain, with the exception of the push notifications, but they're about to get it off. And because it's built with smart contracts, it's a chat app, but it's socialify. So your chat account is going to be like a crypto wallet. You'll be able to send say, hey, happy birthday, mate. Here's 1,000 Satoshis. And send.
And where do I get this
with
app?
A chat message?
Where's the URL? What do I search for?
So the 2 things. So the 2 things I like. I know you're into DeFi. So 2 things I'm going to give you. One is oc.app, which is OpenChat, and that's actually you're interacting with a smart contract. You're not interacting something coming off a web server. It's a smart contract that's serving you that web content. Another, I don't want to get too technical, but the one bit of centralization left is also the domain name, like oc.app. There's a thing coming for that soon. I'm not talking anymore. I'll leave that here. So go and look at openchat.app. And if you go into the network nervous system, which at the moment is, again, smart contracts, creating the user experience, nns.ic0.org, .app, excuse me, nns.ic0.app. And if you go inside there, you can see the governance tokens for the OpenChat service nervous system. But there's just go to oc.app. You can find out all about it. Have a go of it. It's a really, really. It's not forgetting the fact it's running 100% on a blockchain. It's actually just a very cool messaging service in itself, and you can do really cool group chats and things like that. But they've been doing things already, like with Chainky Bitcoin, tipping and stuff like that. And it's all starting, and they've got other crazy stuff coming. So look at that, and that's completely controlled by a DAO. It's insane. 100% on chain, controlled by DAO. The other one to look at is, and there's so many. I'll apologize to all the hundreds of amazing projects, but these are projects where things are happening or something's very notable about.
Yep.
Another one to look at is icdex.io. IC for Internet Computer, I guess. Dex, DEX.io. That's that doesn't use a friendly URL. You'll see some really weird, strange URL. That's because they haven't. It's just coming straight from the smart contracts, and they haven't done anything to make the URL friendly yet. But that's a continuous double auction exchange that provides an order book, and you can do limit orders and market orders and killer fill orders and all this kind of stuff. They're going to, and this is the mind blowing bit, right? They're going to use the Chainky functionality to put every crypto asset on Earth in a fully decentralized exchange that looks like something like FTX, but actually is going to run fully under the control of a service nervous system DAO. Even the user experience is created by smart contracts. Provides exactly the same functionality, albeit it doesn't do margin. It's just like, but at least not yet.
And that's probably a good thing.
It's probably a good thing given all the regulators. Exactly. They're actually based in China. They're based in Shanghai. And I know behind the scenes that thing's got some really clever stuff. So as well as having like traditional order book stuff like you see on like Poloniex or Coinbase Pro or FTX, as well as doing that, they've also got like the AMM model, right, from things like Uniswap and automated market maker.
Yeah.
So somehow they've got some way of having all these different order books and a traditional exchange and still combining that with an automated market maker. So it's a really, really fucking exciting very exciting project.
Yeah.
And I think it shows the future of like DeFi, like full end-to-end decentralization, which also is going to blend with things like, and actually that thing, I believe,
so just to be clear, if I understand what you're saying, and I want to make sure this is a beautiful thought, so I want to make sure it's very, very clear if I understand it correctly. So what you did for Bitcoin by allowing Canisters to operate native Bitcoin in a smart contract, you can do that on any chain. There's no reason why it has to be just Bitcoin. You can do it on Ethereum, you can do it on Phantom, whatever.
It's happening.
So that enables what you are discussing. Basically, you can do a full exchange that operates in this fashion. That's fascinating.
Yeah, because now the smart contract, you can have an exchange smart contract and users can just deposit all their tokens and they're on other blockchains. And I think we did Bitcoin first because this is where blockchain started and it's what inspired me and also it was actually quite involved because you have UTXOs and things like that. So it's not, but the next one is, and the internet computer nodes talk to Bitcoin nodes. The next one is Ethereum and that works already underway. I mean, it's probably couple of months away or something. But once you've got Ethereum, you then got all the tokens on Ethereum and smart contract interoperability, right? So smart contracts on the internet computer will be able to call into smart contracts on Ethereum, which is like, wow. And we've also demonstrated doing things like creating DeFi front ends. We did one for Uniswap, where you can use internet identity, which is this, I won't try and explain it now, but another kind of cryptographic authentication method, which is much more user-friendly, which integrates with a thing called WebAuthn. You can authenticate using your fingerprint, for example, and it's actually interacting with a thing called TPM inside your device where the private key lies and blah, blah. So, you can do Ethereum transactions with a fingerprint rather than like MetaMask. And so all of that is coming, and that's how we're going to like bring all of this stuff into this kind of crazy world computer. And it's all happening bit by bit. It takes time because there's a lot of like R&D going on behind the scenes.
Yeah, it's hard to do.
We can't go wrong, right? It's like you can imagine the nightmares of these cryptographers. Like there's some protocol mistake or security error, and
you got to get it right. Completely.
Yeah. So
we're at the end of our time together, I'm afraid. So, but this has been awesome and fascinating, and I really, really appreciate you taking the time and explaining everything in such incredible detail. One last thing: what websites or Twitter handles do you want to plug, if any? You have the floor.
Well, I mean, there's the internetcomputer.org website. We're always trying to improve that, put more content up there. There's the wiki.internetcomputer.org. You can link from the main one. And I'm on Twitter at Dominic_W. There's DFinity, I think, just as there's a big community growing about the internet computer. You won't hear a crypto press talking about us much, at all, because it's no secret that it looks like some very strange stuff happened just at launch. There's these kind of crazy lawyers that were set on us. It turned out to be they're paid by another blockchain, and I think a lot of people got very worried about the disruption the internet computer was going to pose, particularly a lot of the up-and-coming proof-of-stake, Ethereum killer blockchains. And the sort of financial incentives were such in blockchain that we sort of ended up in a pretty shitty situation where we just went dark. We talked to people and they said, well, we're so excited about the internet computer, but you fell off the radar. And you had to explain, well, guess what? It's been growing. The internet computer exists. It's still got the biggest R&D team in blockchain back here. There's all these hundreds of people, projects doing interesting things. Check it out. But that's something people need to be aware of. You won't hear much about it, which is a shame because I actually think this
Dominic,
whole
I didn't know much about you guys at all. I saw you guys kind of pop up on CoinMarketCap, and I was like, internet computer, what's that? And
it's nuts,
nobody,
right?
none of my friends were really talking about it, right? It was sort of like off my radar, and really, and I looked at it every once in a while, but I didn't really pay that much attention to it. Then when Tom Sayers popped up on Twitter, like going crazy about this latest development,
Well, thanks, Tom. By the way.
I was like, that's really that's Tom's into this. That's interesting. So that's when I started digging around a little bit, and that's how we got here today. So congratulations.
Thanks.
I think you guys are coming out of the shadows at last. So that's
It's cool
congratulations
tech.
on that.
Yeah, it's cool tech, and it's everything's completely new. It's very well thought out, very well engineered. It's been years in the making. When I pivoted from a thing called Paddle. There's a history of the internet computer actually on the wiki. I've been working on scaling blockchains in 2014, and then pivoted to World Computer Work in 2015, which is when the name DFinity came about, decentralized Infinity, and I was part of the early Ethereum community, and it was the World Computer idea that set this thing going. So it was really if you look at Bitcoin to Ethereum was 6 years, Ethereum to World Computer was 6 years, to Internet Computer as well was 6 years. There's just an awful lot of work involved in these things, but I think in the end, we're all blockchain maxis. We're not internet computer.
We
maxis.
are all blockchain maxis.
Yeah, blockchain maxis. I only think that blockchain going away. It's not. Yeah.
We have to end this thing sooner or later, or we'll be here for the next 5 months. But thank you once again. My name is Mark Jeffrey. This has been Hash Rate. We'll see you all next time.